Okay, welcome to IA202, Motor Controls 2. Today we're going to be talking about PLCs. We're using chapter 27 in the book to talk about the PLCs, and it is a little bit redundant because most of you have already taken PLC 1. But just as a reminder and to fill in the motor control view of PLC, we've included in this course. So let's talk about this chapter. As I go through the book, please don't expect to be able to read the book from my camera here. You cannot do that, but you should be able to follow along in your own book. That's what we're meant to do here. So at the very beginning of the chapter, we talk about PLCs, and it gives you a little bit of a background about how we used to have electrical circuits with general lighting switches and that sort of thing, and how they've gotten oh so complicated today, and how you can do programming on these systems. Essentially, a PLC is a hardened computer that's designed to run specialized software for machine control or digital or analog control. All right. So this is good background data. Go ahead and read it. I will mention one little thing. This book comes up with this term here called programmable logic relay. I don't think that's a real term used very much. There was a kind of microcontroller PLC that was sold that was called a smart relay. It essentially was a PLC with only a handful of I/O. But that very small controller, I don't think ever picked up the name of programmable logic relay in common use. This is a term that I think petered out more than 10 years ago. So that's not a common term. So even though I highlighted it, I will also mention, no, don't expect people to use that term. You'll still see it occasionally, but it's not something you'll look really smart if you throw out there. All right, so it talks about different kind of PLCs at the beginning. In the book goes through overall size of systems. It talks about the PLRs, the little computer PLC, and then you got the regular PLCs and something called a PAC, which is also another term not in common usage, which is for very large control systems. And the book talks about what a PAC is as well. These are all interesting terms, but they really don't help you. Mostly people just call them all PLCs at this point. The book talks about how they're used, which is just good background data. We talk about discrete parts manufacturing. We talk about process manufacturing, which they define as food, pharmaceutical, chemical. Anytime you've got batches of material that run through a facility or continuous process. They give you examples of how different processes could work. They give you little pictures of what different PLCs work. Here they show you a very obsolete PLC, which is an Allen Bradley SLC 500 version, which is very obsolete. We still have a few of these kicking around our office, but they are quite obsolete. They talk about PLCs, PLRs, and programmable automation controllers. They just fill in some more definitions here. Starting on page 600, though, they do get into some useful stuff, which is how do you size the programmable controller? Generally speaking, I/O is your count. It's your main count for sizing the PLC. The more inputs and outputs you have, the more processing you require, therefore the bigger the computer chip it needs to be, and therefore also the more racks you need for connecting in the I/O or the capability to communicate to multiple remote racks, remote I/O. So they give you some general topics, general facts here. I don't think any of this is super important. Then it talks on page 601 about controller configurations, and it gives you some examples of it. Typically, PLC is not going to be standalone. I mean, occasionally they can be standalone. It'll sit in a panel and run a particular machine. But in many cases, your PLC is going to be hooked to other devices. A lot of times it's hooked to a computer that'll be running some software like SCADA software. That stands for Supervisory Control and Data Acquisition. It might be hooked to a specialized computer running an HMI. It might be hooked to a custom specialized HMI operator interface panel. It might be hooked to a handheld controller. It might be hooked to a whole network of PLCs. It might be hooked to a lot of different things. A typical PLC, starting on page 603 and 27.2, is always going to have a power supply. Sometimes they're included with the PLC, sometimes they're not. A power supply will provide a good constant voltage for the PLC, the main CPU, plus all the I/O modules. In a general PLC, we talk about the primary components as the power supply, the CPU, and then all the different I/O modules. Sometimes we have specialized cards that slot into a PLC that give you other things. And so I think in the next chapter, we're going to learn about all this stuff. So the first thing they talk about is power supply. Then they talk about the different kinds of I/O, that's inputs and outputs. Discrete I/O means you can have inputs or outputs that are either on or off. Data I/O allows you to communicate with other devices. Generally, I think they're making this a little bit vague. They call this data I/O. Most people call that analog I/O. So the data I/O is probably not the best term to use. Typically, this is called analog I/O. So don't use data I/O if you want to sound smart to your PLC buddies. They're trying to, I guess, imply that there's other kinds of data besides analog inputs and outputs, which is true. There are specialized cards to communicate with other PLCs you can buy. The I/O capacity is the primary measure of a given PLC, how much inputs and outputs you can have in it. And they give you examples of various outputs. Relay outputs, they give you a thyristor output, which is kind of a specialized, unusual one. And they give you some notes about wiring. They give you some notes about how to select your processor, speed. All this is just sort of general stuff. They show you pictures of some obsolete cards from a SLC 500 series processor. This is sort of a sprinkling of useful data on PLCs. So read through it, recognize that hopefully you knew all this stuff already. These guys may be using slightly different terms than we did in our PLC course. All right, programming. In programming world, which starts on page 609, they give you a variety of different methods of programming. For the most part, though, most people program either one of two ways. Today, they either program from faceplate. They might have a device with a faceplate programmer, like the example of a PLR, which is a microcontroller. Here, you can do programming. This is an example of a controller that used to be called a smart relay. And this device could be programmed right from this faceplate. It's really slow and painful to program it from the faceplate, or you could buy software to do the programming like a human person, not a very slow snail programmer. Most people program on a PC now and then download the software to your PLC. And they talk a little bit about ladder logic, talk about the symbols in ladder logic and programming. They don't mention the fact that there are other programming languages for PLCs. They focus on ladder logic, which in my opinion is kind of a shortcoming, but you guys all learned to program on ladder logic, so this is good for you. The good news is this particular PLC, I think that's a 1400, it is not obsolete. You can still buy them today. So look, there's a PLC in here that's not obsolete. Yay! All right, so read through this stuff. We're going to learn about controller scan times, ladder lock diagrams. They give you some basic logic rules here, which in my opinion is a complete waste of time, but you should kind of know what logic rules are. They give you a variety of generic kind of programs to demonstrate how different wiring diagrams can be simulated with a PLC. They give you some basic backup information and storing your programs. They talk a little bit about controller status and fault indicators, including a lovely big old chart showing you all the various status indicators and what the problem might be. And talks a little about networks, which is good. And actually, here we get to some good stuff that we didn't really get into in the PLC course. So I'm going to take back everything bad I said about this book. Here on page 618, we're getting into something. When I say on this book, I meant in this chapter being slightly redundant. In 618, we're diving into an area which is useful to read about, which is the communication network between PLCs. So that one PLC can send an information, a data point, an analog value to another PLC. And it talks about some of the key methods of doing that, including something called field bus. And there's half a dozen different ones out there. And they start listing some of these out there. We talk about Profibus. Right? Profibus is a particular brand of a network. Modbus. Modbus is probably the more popular brand than Profibus. Then we also have DeviceNet and ControlNet. These are all different methods of communicating across a network to gather data from one PLC to the other. And then for some reason, the book switches and talks about timers, how you can set up a timer in a PLC, which is kind of completely the wrong place to put it in there, but it talks a little bit about timers. All right, so now we're getting to page 622. We're going to be talking about applications, and they give you lovely examples. And actually, these are useful examples. These are very common kind of applications out there. In fact, if you had a copy of this book and you got some of my labs, you might find that you have the code here right in the book that were based on what my lab was about. So you've got some example applications here, which are very useful. In this case, you've got a stoplight circuit. So you guys all should be aware of how stoplight circuits work. So this is an example code for the stoplight circuit. And here they show it wired up, and here they show it in code. They talk about welding, industrial robot control. So they're just going through very basic applications. Industrial drive control. Now here we're getting to some more specific stuff to this course. Industrial drive control, we're actually going to do that as part of our lab next week. Industrial drive control. And they just go through at a very high level how these different control systems might be set up in utilizing a PLC. And I guess this is all just good background information. Yeah, I don't think there's anything else that's really important in this chapter. Just read through it. It's all sort of repetitive. The troubleshooting bit, you guys should already have a handle on that. It's very basic troubleshooting, test to see. Based on the lights on, is the input on or is the output on? If the output's not on, then you've got a problem in your wiring. So they go through some basic troubleshooting. So that's all I'm going to go through on 27. Pretty basic stuff, pretty trivial stuff. And